Hey everybody! The purpose of this video is to help us through question 2.13.10 in collaborative statistics. I like this one a lot. It's a very general kind of question. You've got yourself a box plot given to you. No context in data whatsoever. It's strictly just an interpretation of a box plot. So let's remind ourselves what we're looking at with a box plot. It's a pictorial version of the 5-number summary of data. So you've got your min value way over here. You've got your first quartile here. We'll come back to what all this is. Your median right here, your third or upper quartile here, and your max value there. So that's what you're looking at. That's what you're looking at in your box plot. And I personally like to have this as well as a histogram together, if you can. We can't, because we don't have but the 5-number summary. We have no other summary of the data. But that's okay. You can get quite a bit of information even from this. Okay. Notice the average is nowhere up there. There's no average. But we can get an idea of where it would be based on the shape. We'll come back to that. Part A, which quarter has the smallest spread of data, and what is that spread? Okay, so first of all, it's asking about quarters of the data, and that's what a quartile is. A quartile is one of 3 values, Q1, Q2, and Q3, that split the data into 4 equal pieces, with 25% of the data in each piece. So we know for a fact that 25% of the data lives between 0 and 2. 25% of the data lives between 2 and 10. 25% of the data lives between 10 and 12. And 25% of the data lives between 12 and 13, way out there on the tail. So you know for a fact that the same number of data points are here, 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 and here. I don't know what those data points are, and I also don't know how many of them there are. I only have a relative frequency idea here, not a frequency idea. Okay, so all we've got to do is figure out which data ranges, or how wide each data range is. So 25%, these guys are 2 units apart. These guys are 8. These guys are 2. And these guys are 1. So I just answered the question. We just actually answered A and B, didn't we? It's clear that data range between 12 and, or the upper quarter, between 12 and 13, has the least amount of spread. Least amount of spread, and they have a spread of 1. They have a spread of 1. The range of that would just be 1. It's pretty straightforward. In the same, by the same token, 2 through 10 is the most variable, and they've got a spread of 8. Okay, the most variation. And again, you don't know where the points are. You assume they're uniform. You assume that they're uniformly spread throughout the interval. That's an assumption. It's an assumption. C, find the interquartile range. This is a fairly common measure used in certain calculations, as we'll either see or have seen outlier calculations. The interquartile range is just the distance between Q1 and Q3. So if you take the upper quartile and subtract the lower quartile, that's your interquartile range. What's that going to be, 10? It's going to be 10. So that tells us that the middle 50% of the data varies by 10 units from Q1 to Q3. Notice how it doesn't tell you where the median is. This isn't like a standard deviation. When we talked about the empirical rule, you've got the average, and then within a certain number of standard deviations. These are asymmetric with respect to the median sometimes. The median is far to the right, meaning your average is getting pulled down this way. So, more on that. We'll talk more about that at depth later. Are there more data in the interval 5 to 10 or the interval 10 to 13? How do you know this? 5 to 10 or 10 to 13? Okay, well, let's look at 5 to 10. 5, let's see, different colors. This is getting colorful up here. Here's 5. Here's 5. What percentage of data lies between 5 and 10? Good. We don't know. We don't know. So let's come back to that for a second. All we know is that would be this range right here. That's all we know. That's the range of data between 5 and 10. Okay, we'll come back to that. Let's now look at the data range between 10 and 13. Well, that would be here, all the way to the median. Now, what percentage of the data lies between the median and the max. Boom! 50%. Half of the data lies above the median, which is what 10 to 13 would imply. If half of the data lies above the median, can we make a conclusion about the percentage of data that lies between 5 and the median? Exactly. It's got to be less. It's got to be less. I don't know exactly what it is, but I know it's less than 5. It's got to be less than 50%. It's got to be less than what's over here in green. It's got to be, because it doesn't go all the way down to the min. So clearly there are more data points in 10 through 13. Cool. Cool so far. And last but not least, which interval has the fewest data in it? How do you know? It says 0 through 2. Well, we already know that 0 through 2 contains 25% of the data. 2 through 4, that's here. Now, remember, 4 is not one of our measures of relative position that's indicated in the box plot. So the best I can say about 2 to 4 is it's somewhere between 0%. Okay, I'm going to put percentage in here, and less than 25%. I know it can't be equal to 25%. Could it? It could be equal to 25. No, it couldn't be, because the median's over here. I'll just put strictly less than. We know it's less than 25%. So clearly it's less than this. 10 through 12, that's 25%. And 12 through 13, we've already discussed that. That's 25% as well. So 3 of those intervals have exactly 25% of the data in it, or ish, 25% of the data. This interval has to have less than 25% because the median, which is a data point or between 2 data points, is out here. So there you go. You have to have the fewest data points in 2 through 4, only because you're not including the entire range there. You're including a section of the range. All right, hope that helped.